Solving for various angle measurements of triangles. Yes, read the triangle like we read a defense. Let's strategize, let's minimize so we make less errors, and let's kick it off with number 3. This should assist you with the first few. Okay, first I'm given this triangle here and I'm scanning the outside of this triangle. Oh my goodness, there's no exterior measurements. Oh, that's because we have 3 interior angle measurements. And what do we know about this little box or square right there? Yes, that is a right angle. And how many degrees are right angles? Wonderful. They are 90 degrees. All right, the second or third here, yes, I'm throwing this out to you students. If you comment with a second or third option to set this up to solve, yes, I will give you 10 bonus points, equaling 1 practice assignment. But let's take the long way home. All right, so we have 3 interior angles. These 3 interior angles total 180 degrees. So we will set this up as angle plus angle plus angle equals $180 or 180. We have 35x, and we will go clockwise, plus 90 plus 20 equals 180. All right, do we see any parentheses? Can we distribute it all? No. What shall we do? Yes, great job. Let's simplify the left side by combining like terms. My 35x, can I combine it with 90 or 20? No, but what can we combine? Yes, the 90 and the 20. So I'll circle those two as we will combine both those terms. As 35x, do me a favor, just simply rewrite it. 90 plus 20 is, great job, 110 equals 180. All right, so we have a term that's a constant, number by itself on the right side. Ooh, and on the left side, we need to get the term with the variable, which is 35x. By itself, it's hanging out with a positive 110. And what's the opposite of a positive? Yes, it is a negative. Go ahead and subtract 110, but when we get to the operations, what we do to one side of the equation, we do to the other to balance it out as they are equal to one another. Top to bottom, left to right, 35x. Anything below it? No. Go ahead and drop down the big hurt. 110 minus $110, get rid of it. Oh, isolating our 35x. 180 minus 110 is a 70-piece nugget. And we will divide each side by 35, which is the coefficient of the variable, or simply the number in front of the letter. 35 divided by 35 gives us that giant 1. We're just going to write the x because how many x do we see? Yes, just 1. Equals 70 divided by 35 is 2. We're only solving for x. All right, so right here with number 5, this should assist us. Again, with the next like 3 or 4, I'm going to go ahead and scan the outside of this triangle. Oh my goodness, we run into an exterior angle. And angle B is not giving to us, but the 2 opposite interior inside are. So what we can do when we have an exterior and 2 opposite interior, we can set this up as, ready? Exterior angle equals 2 Oppo interior angles. All right, our exterior angle, so not inside of this triangle, but on the outside is the, yes, 115. We'll set that equal to 4x plus 10 plus 7x minus 5. Now, again, if you have a second option, if you're applying some mental math, you want to take this a different route, yes, go ahead and put that in the comments. Thank you. All right, we will look to simplify, not the left, because it's just hanging out with the 115 equals, so we'll just rewrite that. And on the right side, we can simplify. All right, so actually let me do this in orange because I'd like to do, anytime I combine like terms with the entire step, we will do that. All right, beautiful. 4x and 7x, they are like terms. They both share the same variable x, same exponent, which is just 1, the one that we don't see. 4 plus 7 at the 7, yes, 7, 11x. We can also combine 10 and -5, but again, when we combine like terms, remember the first term that we combine will always be read as positive or negative, and every other term that follows as plus or, in this case, minus. We will not say positive 10 because we know it's positive. We'll just say 10. Oh, minus 5, yes, is plus 5. From here, all right, constant by itself. Oh, term with the variable. Need to get it by itself. What's it hanging out with on the same side as equal sign? Yes, a positive 5. Go ahead and get rid of that for me. Thank you. Bring down your 110 equals 11x. 5 minus 5 is our cancel. And we will go ahead and divide each side by 11. So 10 equals, oh, our giant 1, which we just do as x. Great job. Let's move forward. Find the value of x. So again, we have a second or third option. All right, if you'd like to present that to me in class or leave that comment, let's get those 10 bonus points off this video. Yes, let's go. All right, I'm going to scan the outside. Oh, a tick mark. Okay, nothing else on the outside. Oh, another tick mark. Wonderful. We have, so this side is, oh, equal to this side, meaning we have an isosceles triangle. And yes, with the isosceles triangle, we will have a vertex angle and 2 base angles. Now, the 2 base angles will be equal to one another. Let's go ahead and identify the vertex. We can start at any of these points. Oh, Mr. Richards, you have such a great eye. Sometimes I do, not all the time. All right, at the tip of our triangle there, I'm going to do our little dot there. And I'm going to draw a line. I'm going to say, if this runs into a tick mark, which it does off that point, and if it does on both sides, well, we now have our vertical angle. Let's put a V there. Meaning the other two, our base angles, and yes, these are equal to one another. All right, so we know that measurement of angle 2 is 9x plus 2, so the open area is also 9x plus 2. And we now have 3 interior angles, so again, we will be doing angle plus angle plus angle equals 180. We will do our 9x plus 2 plus 9x plus 2 plus 32 equals 180. Yes, we can always take the long way home, but once you start building your confidence, you will see how you can piece these together so differently. And it truly will just take away so many steps, save you a lot of valuable time on your ACT or SAT. All right, no parentheses, not going to be distributing it all. Can we combine like terms? We sure can. 9x, what else can we combine 9x with? Oh, the other 9x. Can we combine anything else together? No. All right, so 9x plus 9x is 18x. Oh, can we combine something else together? I should have said yes, because we do have a different group of terms that we can combine called our constants. So 2 plus 2 is 4, plus 32 is, yes, 36, equals 180. And again, we will try to get this 18x by itself. Well, let's subtract 36 from each side. Bring down your 18x. Let's get rid of this biscuit. Equals. We have the 4 giving us 40, so 144. We will divide each side by 18, giving us x equals 18 times 10 is 180 minus the 36. X equals 8. Let's move forward to number 9. Again, feel free, provide me that second option if you'd like. Oh, what do we notice? What kind of triangle is this again? Isosceles. And yes, I'm going to start right there at our point. And I'm going to run a line down here. We run into a tick. And if that happens off both points, we have found our vertex. Meaning, this guy here is a base. And if the base are equal, well, this one's also 50. And if we know that our measurement of angle 2 is 108 plus x, let's write that in there. Oh, that's on the exterior. And what do we know? It's exterior, which is 108 plus x, is equal to the two opposite interiors. Can you write this as 50 plus 50? Sure. Could you have written it a second way or a third way? Yes. Let's combine like terms. 108 plus x cannot combine. But we can combine 50 plus 50. Oh, so you see how we're just simply saving a step? Yes, great job. Thank you. Let's get this x by itself. We will subtract 108 from both sides. Bring down your x equals 100 minus 108 is negative 8. Again, if you have a second or even third way, I think second there, of setting it up, please feel free. All right, let's read this together. In triangle TRN, all right, so let's draw our triangle here. I have my T, I have my R, and I have my N. All right, TR is congruent to RN. So TR, I'm going to do our little tick here, is congruent to RN. If the measurement of angle T equals 60, find the other two angles. Well, first, let's put in our angle T of 60. Okay. Now, let's find our vertex. I'm going to do our point at R. Yes. Thank you, students. Appreciate it for the compliments on the grade I. Because when we go down to the left, we run into a tick, and we go down to the right, we run into a tick, making this our vertex. And if we know this is 60 and, whoa, base is 60, also our vertex is 60. All right. I kind of wanted to walk you through, but anytime you see the number 60 as an angle in a triangle, all right, the only other two options here, then if our other base is 60, this has to be 60. Now, if the 60 was here, it could have been a little different. But go ahead and call it on that one. Maybe I should have walked you all the way through. That's okay, though. All right. You'll be fine on that. You can always ask questions in class, but this one should get you through the rest of it, too. So, again, it's saying if triangle T, R, N, not my N, twice in a row it just came out terrible. TR, yep, is congruent to RN. If the measurement of angle R equals 40, find the other two angles. Again, I'm going to start up here. You do not have to do this. If you can visually see right away, boom, we run into a tick, and boom, we run into a tick, and 40 is our vertical angle, we do not need to do that, all right? But we also have, two base angles, and these two are equal to one another, all right? Well, the three interior angles of a triangle equal how many degrees? 180. Beautiful job. Now, if we subtract our 40, so let's minus that 40 in red there, that leaves us 140, all right? Now, this can't be 140 and this be 140, but if we take this 140 and divide it by 2, you can also set up the fraction if you like. This is for my new learners. If I put the division there, kind of assist them better than the fraction sometimes. Well, 140 divided by 2 is 70. And that, my friends, completes your triangle and completes the video. Let's go!